The problem is construct binary tree from preorder and inorder traversal. Let's understand the problem. So a preorder and inorder traversal is given to us. So this is the preorder traversal and this is the inorder traversal. And we have to create a binary tree with the help of this preorder and inorder traversal. And we know that preorder is root left right, and we know that inorder is left root right. Okay, so we can say that from preorder the element at 0th index is the root of the binary tree. Okay, so let's solve it. So I will create a hash map and I will put all the elements of the inorder array and its index. Okay, now I will have a root index from the preorder array and left index from the inorder array and right index from the inorder array. Okay, so root index is 0 from preorder array and left from inorder array and the last element from the inorder array. Okay, so I will construct this 3. So this is the 3, so I will construct it. Okay, now I will find a mid. Now I will search this 3 in the hash map. So 3 is here and its index is 1. This is 1, so here it is. So our mid is 1. So with the help of this mid I will split this tree. Mid is actually the root index of the root in inorder array. Okay, so now I will split this. So the left tree will go from left, which is 0 now, to mid minus 1. So mid minus 1 is 1. So 1 minus 1 is 0. Okay, now what is the root? What is the root index of this left subtree? So we know that earlier the root index was 0. This one was the root index. So the next one will be the root index of the left subtree. So it will be 1. And what is the element? And the left subtree goes from 0 to 0. So this is from 0 to 0. So I will construct this 9. So I will construct this 9. Now I will create the right subtree. So right subtree will move from mid plus 1. So 1 plus 1. So it will become 2. Mid plus 1 will become 2 and it will go to right, which is 4 here till 4. So it will go till 4. And what will be the root index of the right subtree? So earlier the root index was 3. Okay, and this is the length of the subtree. So if I will add this length to this root index, then I will get the root index of the right subtree. So it will become 0. I will add 0 and the length 2. So 0 plus 2 equal to 2. So we will get the root index of the right subtree, which is 2. So the root index of the right subtree is 2. While coding, we can find the root index of the right subtree like this. Like we will, with the previous root index, what we will do, we will add the length of the left subtree, mid minus left plus 1, like this. We will do, and we will find the root index of the right subtree. Okay. Now, so this is our right subtree from 15 to 2. So now what is the mid? I will find the mid with the help of inorder hash map. So our root is 2. This is the root is 2. Root index is 2. So element is 20. So I will search this 20 in the inorder hash map. So we got 3. So which is this? In the inorder, this is the mid. So mid is 3. So I will split this right subtree with the help of mid. Mid is actually the root index in the in order array. So the left subtree will go from left, which is 2, to mid minus 1, is like this, and the right subtree will go from mid plus 1, from 4 to 4. Okay, now what is the root of this? Now what is the root of this root index of this left subtree? So it will be just next. So previously it was 2, so now it will be just next, so it will be 3, so it will be 3. Okay, so now which element? So left subtree will lies between from 2 to 2. So which element is there from 2 to 2? It is 15. So I will construct 15. Okay, now I will find the root index of the right subtree. So earlier, what is the root index? Root index was 2. Earlier the root index was 2, this one. So if I will add the length of the previous, if I will add the length of the left subtree, which is length is 2, so 2 plus 2 is 4. It will become 4. Okay, now from 4 to 4, this is the right subtree. So this is from 4 to 4. So the element is 7. So I will construct this 7. So this is how I will construct the binary tree with the help of preorder and inorder array. Now let's code it. So let me stretch this. So first I will find the length of the inorder array. Now I will create a hash map of integer. I will name it as inorder hash map, new hash map of integer. Now I will iterate the inorder array. I will put the elements in order and I. Then I will call a split tree method. I will pass the root index, the left index and the right index. Then inorder hash map or preorder array, then inorder hash map. Now I will create this split tree method, private tree node split tree int root index, int left, int right, then int array preorder array, then map of integer. This is inorder hash map. Okay, so now I will create the root with the root index from the preorder array, new tree node, preorder root index. Then I will find the mid with the inorder hash map, int mid hm.get preorder root index. Okay, then if mid is greater than left, I will create the left subtree, root dot left split tree, then root index plus 1 will be the root index of the left subtree. Then left will start from left only, then mid minus 1 and preorder, and then inorder hash map. If mid is less than right, then I will create the right subtree, split tree, and what will be the root index of the right subtree? It will be root index plus length of the left subtree, mid minus left plus 1, then it will be mid plus 1 to right, then preorder and inorder hash map, and then finally I will return the root. Let's run it. So there is some issue. What it is? So here it will be inorder hash map. There is a typo. Now let's run it again. Now it got accepted. Let's submit it as well. So it got submitted. Okay, so what is the time complexity? Since we are iterating n times, so the time complexity is order of n, and this method is we are doing recursion. So here it will be the height of the tree, order of h. So order of n is more than order of h, so we can ignore order of h. So the time complexity will be order of n. Time complexity will be order of n. And since we are using a hash map and keeping all the elements inside it, so the space complexity will be order of n only. So I hope you have learned something. Thanks for watching.